Hey, what's going on, folks? It's Mike here, and welcome to the D Programming Language series. In today's lesson, we're going to be talking about the cast operator, which allows us to treat one data type as another, or otherwise initialize a data type to another type. Now, casting itself can be seen as something that's dangerous because you're sort of bending the rules of how you're treating bytes of information. But D has some tools that we're going to explore to make casting much more bearable than other programming languages, and let's just go ahead and take a look at what casting is and how we can do so in D and how it improves upon it in these next series of videos. So with that said, let's go ahead and start from the D programming website, go to documentation and the language reference, and we'll go ahead and find under expressions here on the left-hand side our casting operator. So if we go down here to category 16, we'll go ahead and look at what it means to cast an expression. So the way to see the cast operator is with this example that we're casting some type p here. In fact, this is negative p here. Whatever the type is there, and we want to treat it as this other type here. Or in other words, we can look at the actual language grammar here and see this is the type that we are casting whatever's on the right-hand side to be treated as. That is the actual bytes. So here's a few examples here where if we have some integer a, I can cast it and just treat it as a byte here. And you'll notice that the actual data here, how we represent an integer in D, always with 4 bytes, right? We have the size of the type here. It in fact just truncates it and keeps it for this smaller size, a byte, which is just 8 bits here. So we can see how it matches up there. And of course, if we use a short, which is 2 bytes, we get the last 2 bytes of data and so on. So that's the basic idea. And D will allow for this sort of widening or narrowing of certain integral types here. Okay, so we can see some examples of this. For example, if I have a U byte, which is with these values here, and if I want to treat it as a U short, which is shown here, we will in fact just add zeros here, and we can do that with the signed types as well. So just something to keep in mind with integral types. Now we'll also have to talk about casting custom data types a little bit, even though we haven't really talked about structs or classes yet, but I'll still give a few examples. But with that said, let's go ahead and look at the D programming language and dive into it. So what I'm going to go ahead and do here is let's just go ahead and I'll keep my whiteboard open and let's just go ahead and look at an example. Now, in most programming languages, again, you could create some type like this, a equals 7, and then you might want to write out, well, let's just cast that value here. We'll treat it as a long and write out that value here. So again, this is a C style cast. So this is an example, C style cast at runtime. So that means while this program's running, we're just going to say, hey, take these 4 bytes and treat them as the 8 bytes here, extend the actual type here, and so on. So let's go ahead and see if that is allowed. Well, no, it's not allowed. C-style casts are illegal. We have to use cast as we learned from the example here. So again, just to keep the syntax here, we do cast. Then we have the actual type that we want to treat it as, and then the actual value here. Okay, so that's the basic idea. So we can't do this here. Okay, so let's just go ahead and comment that out, that C style cast. And instead, let's go ahead and correct this. Let's do int, or let's write out the line here. We'll do cast to a long for A. And I'm putting some spaces intentionally here just to show you that I kind of group this in my mind together. Okay, so let's go ahead and give this a run, and we can see that this is in fact running. And now another way to look at this too is if we create a new type here, and we cast using our cast operator here on A, let's just go ahead and write out the type ID of our new type here, just so we can see it. Let's give this a run here. And of course, we can see it's a long because we're explicitly treating this data as a long here that we're casting it to. Now, what this actual type holds, let's go ahead and put a comma here and holds. And we'll put the new type here and give it a run. And you can see it still holds the value 7. So this is a sort of successful cast, and this is what we can do in the D programming language. So with that in mind, I want to talk about 2 maybe more advanced examples, I suppose, here. And the first is something that we haven't truly dove into yet in this series, so you'll have to bear with me, and maybe you have some other programming experience with other languages. But what I want to do here is just create two new types here. I want to create a base type, and I want to create a derived type, and it's going to inherit, and let me be specific since we're just introducing these with single inheritance, to create derived, which is a type of base here. Okay, so that's the basic idea, that we have these new types that we can instantiate. And what I want to show you when it comes to casting in the deprogramming language is, let's go ahead and create one of those derived types. So casting with new class types. And in the deprogramming language, just like in Java, we need to allocate here. So derived equals new derived type. And then I'm going to create a base, which is going to be casted from the derived type D that we just created. And what we can do to see if this is valid in our hierarchy, meaning if I create a base class here, and I have something that's deriving from it, which is my derived class, can I in fact treat my base as a type of this derived class here? Okay, so let's go ahead and see if that works, sort of casting upward in the hierarchy. And the way that we can do that is we can say if B is not null, okay? And we'll go ahead and write and say, yep, can cast B into derived, okay? So let's go ahead and compile this. And in fact, it looks like we can. Let's actually write out the type here, type ID of B, just so you can see that. And it is being treated as a derived object. We're casting it, and in fact, derived is a type of base. Okay, so that's just an example there of this working. And for those of you, again, who have object-oriented experience, let's go ahead and see if we can do this the other way around. Let's just create a base here. I'm going to call this BB and equal the new base here. And then let's create a derived class, DD, just for a second example. And then I'm going to cast this to the derived type, because I want it to be derived. So let me go ahead and set that up. And from the BB class here. Okay, so let's go ahead and see if we can do this. So if DD is not equal to null, and let's do not is, okay, that's sort of a D style thing that we can do here. Write out cannot cast upwards and treat DD as a base type. Okay, so let's go ahead and see. Well, let's say we can cast upwards here if that is successful. Okay, so let's go ahead and give this a run here. And I don't actually see this message printed out here. Okay, so we can test for, if a cast was successful here. So let's just go ahead and be explicit and say else if DD equals null. Or again, we could just say is null. Right line cannot cast upwards and make, and I guess I should be a little bit careful with upwards and downwards and sort of the direction. I'm just gonna say cannot cast to derived, or I should say cannot cast BB into derived class here. Okay, so let's go ahead and see if that prints out, just so that we can see that we can have this failure. So for folks coming from a C++ programming language, you might have used dynamic cast, for instance, and that's sort of the behavior that we get with cast here. We don't have to think about static cast and all these dynamic cast and reinterpret cast, etc. We just use cast for that. Okay, so that's just an example with classes. Now I want to go ahead and show you a few more examples here. So this is an action-packed video here. And this one would be an example where you have a block of bytes, okay? And you might have this, for instance, if you have a series of network data. So for instance, oftentimes if you have a network, I'll just go ahead and draw it by my side, you might have a stream of bytes here. And this is sort of your payload. Again, this is talking to our network programmers, and you might have to, interpret some chunks of these bytes as different units, whether they're integers or the type, sort of the packet format or what the actual payload is. So let's go ahead and look at a little example here. And to do this, I'm going to use the memmove operation here from C. So you'll see this in a moment. But basically how I'm going to set this up is I'm going to go ahead and create an integer here. Let's just set it to 57, just to be, something random enough here. And what I want to do here is create some artificial payload. And this might be 100 bytes, 1,000 bytes. I'm just going to happen to make this 4 bytes. There's no reason I could make it 40 or whatever. Just 4 is all we need for this example. And that's going to be my payload. Okay. So what I might want to do here, then, if I'm writing a application, is move this value 57 into payload. Because an integer, remember, is 4 bytes. So I have 4 bytes here. So I should be able to just move those 4 bytes here. And in fact, I can. And this is why I need this library here to do this memmove function call. So what I'm going to do here, the destination is payload, and specifically at the 0th position. So I'll be explicit about this. The address where I'm grabbing the data is X. And how many bytes am I moving? Well, the size of X here. Or I could actually just put in 4, just to indicate again that I'm moving 4 bytes here into my payload. So let's illustrate this, again, just to be clear here. I have X, which takes 4 bytes. I've allocated a byte array here of 4 bytes. 2, 3, 4. So I'm just moving here, starting from the first position here, whatever the bytes are that represent, 57 here, into this memory here. So it's going to get the same exact copy there. Memmove is, I'm just copying in the data there. Okay. So what would happen now if I'm on the other side of some system and I want to look at this payload and say, hey, I'm expecting the first, 4 bytes of this payload to be an integer. Okay. So how could I get back that information? Well, the little trick I can do, again, with casting is to get the value back. So I'm going to create an integer where I want to store this. I'll say get value back from payload. And now what I'm going to actually do for this is cast again. So I'm going to cast it into an int. And I want it from this payload here. So let's go ahead and try this much and see if this works. And it's already saying, hey, you can't cast an expression payload, which is bytes, to integer. So we have to do a little bit of trickery here in order to get this to work. And this goes back to pointers, where we want to think about things in terms of bytes. Okay, so thinking about pointers, maybe I can think about this as a pointer to some integer in my payload. Okay, so let's go ahead and try that and see if we get a little bit closer. And that says, well, we cannot implicitly convert the expression of address of our payload of type int star to int. Okay, so what does this mean here? Well, we want to treat some memory that we're pointing to and cast it into a int star here. Okay, so what we need is the address of our memory. Okay, so that's this right here. We want this address here of this. And then we want to treat it like we have a pointer. So I'll just draw another arrow here that's pointing here. Okay, so let's see if that works here. So now we should be able to have a pointer to some memory here. So this should be working in a sense. The right hand of the equation we'll say is working. But we've still got one more step here where we need to convert int star to int, right? We need to match this type with what's on this side. So what we do then is, well, if I want the value that's pointed at something, I dereference it. Okay, so I'll put a star there. And then now I can actually get this value here. So now if I write out the line here, get value back from payload, and let's actually print it out here as well. And let's see what's going on here if we do this. And let's see if that in fact prints out 57. Okay, so in fact we do get 57 back. So again, just to go through those steps, what I've shown here with casting with a block of bytes, I have imported a C library, Okay, that's the standard C string library, which has operations like memmove. I took an integer, I packed it into some bytes, okay, this payload here. And then I said, okay, let's essentially copy in these 4 bytes into our payload, or just this byte array. And then something might happen in our program, or again, if you have a network program that's just sending bytes back and forth, I said, well, let's get the value back. And again, we want to interpret, wherever the bytes or bag of bytes that we're getting here from our payload. And again, maybe let's be a little bit more explicit just to match what we did here. Let's say, starting from position 0, because we might play around with this a little bit here in a second here. We'll retrieve from the address of our payload, we want a pointer to that data, and then we're going to dereference that data because we want an actual integer, and we'll store it here. Okay, so let's go ahead and run that, and again, it still works. And just for fun, because you might use this in a networked application, let's go ahead and create another value y, for instance. Let's go ahead and increase our payload so that we can have 8 bytes. Again, just to show you how this casting works. This time we're going to move things to the 4th position. So let me make sure I count that right. 0, 1, 2, 3, 4 here. I might be off by 1. We might have to do this twice. But let's get the second value. So get second value. This time from our payload at 4. And let's see if we get the value, I don't know, 58 here. Okay. Let's go ahead and do this here. Get second value. And then we'll print out get second value. Okay. Let's see if I did it right or if I'm off by 1. Looks like I am just off a little bit here. I got to add y.size of and make sure I'm copying in the right memory here. Okay. Okay, so this looks like now we got 57 and 58. So this is a way to cast from this byte array and just treat, again, it's sort of showing you how the casting operator is working. It's saying, okay, from this address, we're just going to grab the next 4 bytes. Hopefully they're there. You might have to do some validation, and we'll talk about that maybe at some point, or you can post this question about it. But that gets us the second value back. So again, this could be very useful in network programming, or if you're serializing or deserializing values, for instance. All right, now before I leave you on this lesson, I want to go ahead and tease you with something else here. A teaser for next episode. So make sure you subscribe so you don't miss it. Let's just say I have some value here that's like 77 here. And then I'm going to write out concatenate a string. And I want to do something like cast to string to some other type here, because we've kind of seen how we can use cast above here and, just treat any type. Like, can we use a string, or, what do we have to do here? And then we have some value here. So some value. Let's see if this works here. I try to run it and says, hey, I don't know how to cast a type of an int to a string. What about a char array here? Maybe it's some weird mutation thing. Nope, still not working. So it turns out we are going to have a useful library. And we're going to stay tuned for the standard convert library, which has some things like cast from and a way to cast to string. Okay, so check that out in the next lesson. All right, folks, so I hope you enjoyed that lesson. Hopefully it was useful and you learned a little bit about the casting operators in D. Again, it's a little bit safer than other languages, and there are some nice checks you can do at runtime to make sure that you have successful casts. And we did even a little fun one just to show you again how data is packed into bytes. At the end of the day, that's all of our systems. All right, folks, thank you as always for your time and attention. Make sure you subscribe, make sure you give this a like, and if you have questions, make sure to join into the discussion below.